The FIA just dropped the biggest bombshell in Formula One history, and it's going to flip the entire grid in 2026. Active Aero that moves mid-corner. Engines that are half electric. No more MGUH. This isn't an upgrade, this is an F1 revolution. Teams are already panicking, drivers are warning of chaos, and if they get this wrong, we could see champions fall and underdogs rise. This is the future of Formula One, and if you want to stay ahead of every twist before the 2026 season explodes, hit that subscribe button right now before the lights go out. The FIA has officially locked in the technical blueprint for the 2026 Formula One season, and what's coming is nothing short of a mechanical and strategic revolution. We are talking about the most significant regulation shift since the hybrid era began in 2014. These changes go far beyond the usual tweaks, they reshape the very DNA of an F1 car. Aerodynamics, power units, race strategy, and even the role of the driver will be redefined. This is no longer just about performance, it's about survival. At the center of this transformation is active aerodynamics. Starting in 2026, cars will be equipped with movable front and rear wings that adjust dynamically throughout the lap. Unlike DRS, which operates in limited zones and only under specific conditions, the new active aero system will function in real-time, opening and closing wing elements during acceleration, braking, and cornering. Teams will have to design cars that are not just fast, but intelligent, responding to aerodynamic needs on the fly, controlled by onboard systems and driver input. But it doesn't stop there. Under the hood, the power units will be fundamentally different. The internal combustion engine will be reduced to 400 kilowatts, down from the current 550, and the electric power will be doubled to 350 kilowatts. That means hybrid systems will no longer be a support tool, they'll be nearly half the car's total power output. This shift demands brand new battery systems, energy recovery logic, and deployment software. F1 cars will become rolling data centers, machines where code is just as important as horsepower. The MGUH, the component that recovers energy from exhaust gases, is gone. This simplifies the engine structure but also removes one of the most advanced energy systems in the sport. Teams now face the challenge of generating and deploying electric power without this vital component, relying instead on more aggressive braking energy recovery. It's a reset that forces every power unit supplier, from Mercedes to Audi, to start fresh. Past dominance no longer guarantees future success, and that opens the door for chaos in the pecking order. The FIA's sustainability push also hits full throttle in 2026. All cars will run on fully sustainable fuel, not a blend, but 100% carbon-neutral fuel. This means teams and fuel suppliers must re-engineer combustion parameters to match the new fuel characteristics without sacrificing power or reliability. It's a monumental task. The challenge is to replicate the explosive energy of traditional fuel in a formula that's environmentally responsible and stable enough to survive the brutal demands of racing at 200 miles per hour. For teams, the implications are enormous. Every decision made now, from chassis concept to engine layout, will echo into 2026. Any mistake in interpreting the new rules could doom a car's competitiveness for years. The cost cap era means fewer chances to redesign once things go wrong. That puts pressure on departments that used to operate in isolation: aerodynamics, energy recovery, cooling, software, to collaborate like never before. In 2026, integration is king. Silos will kill performance. And for fans? This is the dawn of a new era. The cars will look different. They'll sound different. They'll behave in unpredictable ways. Battles won't be decided by straight-line speed alone, but by who controls the aero, who manages energy better, and who adapts faster. The FIA isn't just writing a rulebook. It's reprogramming the sport. And the question every team must answer is simple: can you rewrite your story, or will 2026 be the year you disappear? Active aerodynamics will be the headline change that reshapes both how Formula One cars are built and how they're driven. Unlike DRS, which only opens the rear wing in specific zones, the 2026 system allows continuous movement of both the front and rear wings in real time, across the entire lap. This means the aerodynamic load on the car will no longer be a fixed value. It will change from corner to corner, straight to braking zone, adapting to the car's needs like never before. The car becomes a living machine, constantly tuning itself mid-lap. For engineers, this completely flips the design philosophy. Instead of optimizing for maximum downforce or minimum drag, they now have to build a car that's flexible, capable of delivering different aerodynamic states instantly without destabilizing the platform. That means recalibrating the suspension, the weight distribution, even the tire interaction with the surface. Every element has to tolerate and cooperate with these sudden changes in airflow. It's no longer about building the fastest car, it's about building the most responsive one. This system introduces a software war. Teams will need to write advanced logic that controls the wing behavior not just for ideal laps, but for every scenario imaginable: defending, attacking, saving tires, reacting to rain, or even managing battery temperature. Aerodynamic profiles will be stored and deployed automatically based on telemetry. The key advantage will no longer be just mechanical, it will be digital. The best coders in the factory may have more influence on lap time than traditional aerodynamicists. For drivers, the change will be immediate and visceral. Corner entries will feel different as the front wing lifts or lowers under braking. Mid-corner rotation could become more sensitive as the car shifts aero balance dynamically. Exits could vary lap to lap depending on the settings used. It will require a new level of mental processing. Drivers won't just manage tires and battery deployment, they'll also need to sync with a moving aerodynamic system that demands precision and trust. A misread of the system's behavior could result in understeer, snap oversteer, or worse. Overtaking will be transformed. Instead of waiting for DRS zones, drivers may find opportunities to pass in places previously impossible. Defending will also evolve by changing aero profiles mid-battle. A driver can increase grip in corners to hold position or reduce drag to counterattack. The cat-and-mouse game between offensive and defensive strategy will now be partly automated, partly manual, and always unpredictable. Each battle becomes a race of aero logic, not just bravery on the brake pedal. From a race strategy perspective, teams can now factor in aero modes as part of tire and energy management. Want to push for a few laps without chewing tires? Lower wing load. Need to stretch a stint on used rubber? Increase downforce mid-corner and coast more. These aerodynamic profiles will be deployed like ERS maps, giving race engineers an entirely new toolkit. But every mode change also increases risk. Get the timing wrong, and you could overload a tire or destabilize the car when the driver least expects it. This is more than an aerodynamic update. It is a psychological test, an engineering war, and a data battlefield. The teams that treat active aero as a driving aid will fall behind. The ones who build entire philosophies around it with cars, drivers, and systems built in unison will thrive. In 2026, the fastest car may not be the one with the most horsepower, but the one that dances best through corners, changing shape as it goes. The aerodynamic arms race has just begun. The 2026 power unit regulations represent the most radical engine reset Formula One has ever attempted. The traditional balance of power is being completely rewritten. Internal combustion will no longer dominate performance. Instead, the FIA has mandated an almost equal split between electric power and combustion, forcing teams to rethink what engine performance even means. This is not a refinement of the current hybrid era. It is a clean break from it. Under the new rules, the internal combustion engine will be capped at around 400 kilowatts, while the electric motor will deliver up to 350 kilowatts. That means nearly half of the car's total power output will come from electrical deployment. In practical terms, drivers will rely on battery energy far more than ever before, especially on corner exits and long straights. The engine note, throttle response, and acceleration profiles will all feel very different compared to today's cars. One of the biggest shocks is the complete removal of the MGU-H. For years, this system allowed teams to harvest energy directly from exhaust gases, making modern power units incredibly efficient but also extremely complex. The FIA believes removing it will reduce costs and attract new manufacturers, but it also wipes out a decade of engineering knowledge. Every team now has to reinvent its energy recovery philosophy from scratch, with far less margin for error. This puts enormous pressure on battery technology. In 2026, the battery is no longer just a support component. It becomes the heart of the car's performance window. Teams must design batteries that can deliver repeated high power output without overheating, degrading, or failing across a full race distance. Cooling systems, packaging, and weight distribution are all affected. A poorly designed battery could make a car fast for 5 laps and unusable for the rest of the race. Sustainable fuel adds another layer of complexity. The FIA has confirmed that all 2026 cars will run on 100% sustainable fuel, not a blend. While this fuel is designed to match the performance of current race fuel, it behaves differently under extreme pressure and temperature. Engineers must recalibrate combustion timing, ignition strategies, and thermal management to extract performance without sacrificing reliability. This is a massive challenge, especially when paired with reduced combustion power. From a competitive standpoint, the engine rules could completely reshuffle the grid. Manufacturers that master electric deployment, battery efficiency, and software integration will gain a decisive advantage. Raw horsepower will matter less than energy management and consistency. Teams that fall behind in this area may struggle for years, because engine architecture is largely frozen once homologated. A wrong decision now could lock a team into mediocrity for an entire regulation cycle. Ultimately, the 2026 engine formula reflects the FIA's vision for the future of Formula One. Cleaner, smarter, and more technologically relevant. But it also raises serious risks. The learning curve is steep, the costs are high, and the pressure to get everything right from day one is immense. When the lights go out in 2026, the winners won't just be the fastest drivers. They will be the teams that understood this engine revolution before anyone else.